Hello guys, welcome back to my YouTube channel. Today we have this question on the board. X to the power of 2 minus y to the power of 2 equals to 24. And then of course xy equals to 35. What will be the value of x plus y? Now, there are ways we can, but this is simultaneous. This, we can regard this as equation 1 and equation 2. And not only that, there are two variables, x and y. So we can regard this as simultaneous. And then we can also use method of substitution, elimination, or whatever method, depending on what you are looking at. But from the nature of this question, it will be kind of difficult to want to use the direct method that we all know, because this is going to just make the whole thing complicated. So therefore, there is a special method I'm going to apply that will make this equation easy to solve, and that will at a glance bring out this x plus y result. So I want you to follow me as we solve this question. But before we do that, please, if today is your first time coming across my YouTube channel, please, I want you to kindly subscribe. And then of course, if you are a returning subscriber, please, or maybe you have seen my videos before, please, I want you to, and you are yet to subscribe, please, I want you to kindly ask that you subscribe, okay? Give me a like, and then of course I want to know what you think about this question. And of course, if you know of other ways that can give us a faster solution, please, I want to see it in the comment section. Thank you, and then please, let's go ahead and solve. So first we have our solution, then I bring down the questions. So I regard this as x squared minus y squared equals to 24. Call this equation 1, and then of course xy equal to 35. I call this equation 2. So from equation 1, I have x squared minus y squared equal to 24. So now recall that from algebra, recall that a squared minus b squared equal to a plus b bracket a minus b. Now the reason is simple. This is a difference of two squares, and the identity for difference of two squares is a plus b times a minus b. So these two factors will give us the product of these two factors will give us the result of a squared minus b squared, and that is called the difference of two squares. Now I'm going to apply this law, this rule here, into this equation, and so the equation becomes x plus y bracket x minus y equal to 24. And there's something we also need to do here, and that will be that I'm going to take the square of both sides. I'm going to take the square of both sides, the right hand side and then the left hand side. So that will give me x plus y times x minus y squared equal to 24 squared. Okay? And then I go further to say this will give me, once I apply this power law into these two, into the bracket, of course you know that there is this rule that says we have ab all raised to power 2, then all raised to power n, or whatever power, going to give us a to the n and then b to the n. So this rule is very important. So I'm going to apply this rule here. So this rule will give me x plus y all squared, then x minus y all squared equal to 24 squared. So having said that, further, this one when expanded, if I go ahead to expand this, I'm going to have x squared plus 2xy plus y squared. Then of course this will also give me x squared minus 2xy plus y squared equal to 24 squared. Okay, so now I'm going to move my solution to this side of the board. So from here now, don't forget that from equation 2, y is 35. So that will come in handy here. So xy is 35, and so I'm going to have, from here, I'm going to have, from this end, so I'm going to have x squared plus 2 times 35 plus y squared. Then of course I have x squared minus 2 times 35 plus y squared all in bracket equal to 24 squared. Okay, so no, that is hidden. Please allow me to repeat this part. I'm going to repeat this part. So I have, so from that end I have x squared plus 2 times 35 plus y squared times x squared minus 2 times 35 plus y squared bracket equal to 24 squared. So I hope that is taken. Now, further I'm going to have x squared plus y squared plus 70. Then I have x squared plus y squared minus 70 equal to 24 squared. Now, so I'm going to also go ahead to do something and say, let p equal to x squared plus y squared, and then let q equal to 70, so that the whole of these products, the left hand side now becomes p. I think that's yes. So the whole of the left hand side becomes p plus 70 bracket p plus q minus p plus q times p minus q equal to 24 squared. So of course we know that this will also give us, this is the factor of difference of two squares. It's a factor of difference of two squares. So instead of having this can now come back to p squared minus q squared equal to 24 squared. So what I'm going to do now is to move this to the other side. So I have p squared equal to 24 plus q squared. Yes. Now don't forget that p is equal to x squared plus y squared. So p will give me x squared plus y squared. And then of course we have the square equal to 24. This is 24 squared, then 24 squared plus q is 70. So this is going to give me 70 squared. So I have x squared plus y squared all squared equal to 24 squared is 576 plus 70 squared is 4,900. So x squared plus y squared all squared will give me, so 4,900 plus 576 674 5,476 5,476. So I'm going to take the square root of both sides rather. So I have x squared plus y squared all squared equal to, okay, plus or minus square root of 5,476. So this square and square root will go, and then of course I'm going to have so I'm going to have that. So from there I'm going to have x squared plus y squared equal to plus or minus square root of 5476 is 74. Okay, so now recall that a plus b squared is the same thing as a squared plus 2ab plus y squared. Oh, plus d squared. And therefore, if I make a squared plus b squared as my subject, a squared plus b squared will give me a plus b squared minus 2ab. So if I make a substitution, if I apply this to this side of the equation, so I'm going to get x plus y squared minus 2xy equal to plus or minus 74. And x plus y is what we are looking for. And then of course x plus y is xy is 35. Don't forget that xy in our original version is 35. So I'm going to put that here. X plus y all squared minus 2 times 35 equal to plus or minus 74. So we have x plus y all squared equal to plus or minus 74 plus 70. So I'm going to have, so there will be two solutions, but first we're going to have x plus y squared equal to plus 74 plus 70, or x plus y all squared equal to minus 74 plus 70. So this will give me x plus y all squared equal to, this will give me 144, or x plus y squared equal to minus 4. So let's solve for case 1. So this will give us case 1, and then this one will give us case 2. So let's solve for case 1. Let's solve for case 1. For case 1, we have x plus y squared equal to 144. X plus y will give us plus or minus square root of 144. X plus y will give us plus or minus 12. Okay? So that will be the value of, don't forget we have to find x plus y. So then for case 2, x plus y squared equal to minus 4. So x plus y equal to plus or minus square root of 4, or minus 4 rather. And then of course we know that yes, so we have that. So we break up this minus 4 to 4 multiplied by minus 1. And of course we know that, so we're going to get plus or minus square root of 4 times square root of minus 1. Square root of minus 1 is I. So we have plus or minus square root of 4 times I. So this gives me plus or minus square root of 4 is 2. So these are the solutions to this problem. Please let me know what you think in the comment section. And then of course I am going to see you in my next video. Thank you. Bye bye.